Hello everyone, it's July 27th. Alright, today's goal, we finished the challenge and I have a little bit kinda to go through this, trying to understand this whole solution. Okay, so that's the goal today. Okay, is an anagram. True if T is an anagram of S. Just counter, right? Unicode characters. I don't know, does a counter work? Yeah, it doesn't really matter, that's not the point for today. Just want to get this done as fast as we can, and then I can start understanding Lee to 15's solution. Yeah, I think this one we just need to do a counter, and we just return counter S equal to counter T. I think that shall be it. Yeah, that shall be it. $242. Okay, so we're done with this. Okay, so we will first create a monotonic stack. Let's just walk through an example. What example do we have? Yeah, we have example, I remember. One, three, one, two. Okay. 1, 3, 1, 2. What do? We will first create a right array, which is a monotonic array going from left to right. So if we have 1, 2, 3, 4, and then the original array will be 4, 4, 4, 4. And then for I and n, well, stack. Oh wait, hold on. That's the right array. We also have the stack. I don't think we use the stack. No, we use the stack just for this purpose. So we'll append the index, okay? And then next one coming is 3. If it's larger than, then pop no, so we push in 1. Now 1 comes in. Then this larger than, then we're gonna pop. And when we pop this, we will say right 1 will equal to I. What does that mean? That means, let's write it first. So we pop 1 out. So write 0, 1 will equal to I. I right now is 2, so it will be 2. And now we'll put 2 inside. Next, 2 comes in. 2 comes in as 3, append. And that's it. The right doesn't change. It's just 4, 2, 4, 4. That's what the right looks like. And what does that mean? And we don't do anything with it. Because it only popped once. It means I don't know. Okay, then we have a left. Left start with O minus 1. Okay, then we go right to left. So well, stack. So stack append I, so it will be 3. And then 1 comes in, and the top of the stack is larger, then we will pop. So we pop 3, so that will become 2. Pop 3. So the reason we popped is because at this position, the next one is smaller than me. That's why we pop. And here it is, the one in front is smaller than me. And then we push 2 in. Next is 3, so we put 1 just on the stack. Last one is 1. 0 comes in, and it's smaller, so I will pop 1, and I will put 0. And it's equal, so I pop this 2. That becomes 0 as well, eventually. So that becomes minus 1, 0, 0, 2. What does this say? Well, it just says at position 1, I have something smaller, which is 0. At position 2, I have something smaller or equal. And at position 3, I have position 2 is smaller than me. Okay? The other way, at position 1, I say position 2 is smaller than me. Okay. How do we use this array? I don't know. Keep looking. So we have ACC, it's the cumulative sum of cumulative sum, right? Which is basically, we think about 1, and 1 plus 1 plus 3, and 1 plus 1 plus 3 plus 1 plus 1 plus 3, right? And then 1 plus 1 plus 3 plus 1 plus 1 plus 3 plus 1 plus, actually 3 plus 1 plus 2. That's what it is. Okay, so that's our ACC. Okay, so for I in range, so I go through everything. I say L and R in the left eye and right, no, left eye and right eye. So what do these give me? Well, this gives me, like I would say, right eye gives me the index of the value that is smaller than me to my right. Okay, the immediate one to my right. And the left give me the smallest one on my left, immediately on my left, smaller or equal to on my left. Okay, so left eye, right eye gives me the smallest one, no, the most recent, smallest value on my left. And R is the most recent, smallest value on my right. Okay, and then I say ACCI, that's the cumulative, right? Minus ACC maximum left and 0. Maximum left and 0. Okay. Maximum left is 0. what does this one give me? ECCI is up to me, right? And then the left, which is just the left thing, the smallest value on my left, the closest, smallest value smaller or equal to me on the left, which means in between, I rule, okay? So I think LACC is the S in between that I was talking about, because this basically means I want to find out, I want to remove everything to the left of something smaller than me, right? So in between L and myself, I am the smallest value. So by doing this minus, what do we get? Let's see. I think we had this, I had a similar idea, right? So if I do this minus, because this is going to be plus this, and I have a minus. Let's say if I do this minus this, 0, 1, 2, 0, 1, 2, minus 0, 1, what I get is 1 plus 3 plus 1, which is this thing. Okay. And if we do this minus this, then I get 1, 3, 1, and then 1, 3, 1, 2. So what I get is from left all the way to this, and from left all the way to, based on if we have, how many we have. Okay, so left to this, so it's this plus this plus this. Okay, I have a mental image of what this one means. Now we do the right. Okay, so ACCR is the value on the right that is smaller than this. Okay, so I find a value to my right that is smaller than me, and I use that to minus myself, which means I'll get the in-between. Okay, but that in-between is a little bit weird. That in-between is not starting from the right, that's still starting from the left. So for R, it's still going to be this, this. Okay, that's the right. Okay, so we got the left, we got the right, and supposedly on the right, I am also the smallest. Okay, therefore they will multiply this. So what I think is they're trying to find all the subarrays. Okay, the sum of all the subarrays with AI being the smallest value. So we just multiply. So this is going to be the total sum of all the subarrays. Okay, so now we have a little mental image. So I say A1, A2, A3, A4, and if I'm looking at A3, okay, and I say this, so A1 to A3, A2 to A3, these are based on A3, and A4 to A3. So all these are the subarrays, with A3 being the smallest, because we have, maybe say A5, maybe it's even smaller, or A0 is a bit smaller. Okay, so what I want is A3 plus A2 plus A3, right? And A1 plus A2 plus A3. That's on the left side. And on the right side is going to be A3 counted, so A3 plus A4. So So that's starting. But A3 can also be, we also have crossing, right? So we have, let's say, A2, A3, A4. You know what? It'll be actually easier to think this based on A4, right? Everything that ends in A4, that either it has to end on A3 no matter what. So okay, that's end on A3. Now we have to end on A4, which is A3, but not A4. A3 plus A4, A2 plus A3 plus A4. A1 plus A2 plus A3 plus A4, right? So these are all the conditions. These are everything that contains A3. Okay, so what we have now, let's say we have A0, right? A0 plus A0 plus A1, A0 plus A0 A1, A0 A1 A2, A0, A0 A1, A0 A1 A2 A3, A0, A0 A1, A0 A1 A2 A3, A0 A1 A2 A3 A4, last one, A0 A0 A1 A0 A1 A2 A3, A0 A1 A2 A3 A4, and A0 A1 A2 A3 A5. Okay, so that is our prefix sum, the prefix sum of prefix sum. So with that in mind, what we want to find is A1, A2, A3, A2, A3, and A3. Okay, so we want to find up to A3, A1, A2, A3, and A2, A3. There ain't no A2, A3, and we also want A1, A2, and also A3 by itself. So we can minus, right? Let's say we have A3 minus A0, the position A3 minus position A0, right? So position A3 is 0, 1, 2, 3 is this thing, minus position A0, okay? So this thing minus position A0 is A0, so this gives us, oh, shoot, I messed up, shoot, A0, A1, A2, A3, I missed one, A0, A1, A2, A0, A1, A2. Okay, anyway, but 0, 1, 2, 3, so from 3 minus A0, what we have is A0, A1, A0, A1, A2, A0, A1, A2, A3. So not exactly what we need, but close, right? So if we do this, and if we do, and it will be L. The left is minus 1, which just means left is nothing. It will be 0. So minus A0, which is A0 by itself. So yeah, so that's that. And alright. Minus Ri. So let's say A4. So 0, 1, 2, 3, 4 minus this. Then what we have, so this minus this, what we have is just A0, A1, A2, A3, A4. So this minus this is everything end up here, right? And if this thing minus this is just everything minus here, and everything here, and everything here. Okay. But how? It doesn't work. And left count, yes. Right count, yes. That is the number. But r minus I. You say count how many here. And I minus L. Count the number here. Oh, R is here. This is R. My bad. This is L. And this is R. It seems to have initial 0, so actually this one is longer. Okay, I see. So now we're talking about this minus. That's true. Now it's actually A5 minus A3. So 0, 1, 2, 3, 4, 5 minus this 2, 3. So it's going to be to 4 and 5. So I'll do it to 4 and A0, A1, A2, A3, A4, A5. Now what? We want to use these two sum to find this. How? The right times left minus left times right. Anyway, so I have this, so we need to produce this whole thing, right? This whole thing. And if we observe, we see that 1, 2, 3, 4 appears. Is that how we're going to approach it? 1, 2, 3, 4 appears once, and 2, 3, 4, and 3, 4. Yeah, 1, 2, 3, 2, 3, and 3. So A3. So but first of all, we need to remove A0. Okay? But now we cannot remove. So if we times 3 on the right and 2 on the left, and then we do minus, then the A0 will be gone. Okay? Now, how many A1s we have? We need 1, 2. We need 2 A1s. And we have on one side is 2, the other side is 1 to 3. Okay? So if we do the same thing, wait, hold on. This one minus this. Yeah, A0, A1, A0, A1, A2, A0, A1, A2, A3. Yeah. And this is all the way to 4 and all the way to 5. And how are we going to get rid of 5? Yeah, R should be the one that's smaller than me. So R should be this one. Which doesn't make any sense, right? No, it does not make any sense. Let's understand the accumulate wrong. Hold on, what's accumulate? Okay, and accumulate of accumulate. So we have a 0 at the front. Now we have this. Now we have these together, so it will be, that's actually empty. 0, 0, 0, 1. Add this. 0, 0, 1, 0, 1, 2. Right? And this add to this. 0, 0, 0, 1, 2, 0, 1, 2, 3. So that's gonna be 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 2, 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. Yeah, that is correct.
Mm.
Man, can't even parse his solution. A5 is the smaller one. Are we trying to find everything that with? Yes, it's with the current one as the smallest one. So I cannot reach A5. Yeah, that's something I don't understand. Let's say we don't have A5. That's kind of the thing that's bothering me right now. Yeah, let's don't get A5, and let's just say we want to get to A4. Okay? And now we'll just do A4. Right. Minus A3. We'll just get all the way to here. And because of that, the total number that ending in A4 is equal to 3. Yes, that is true. So I need 3 times this A4. Good. But when we do that, everything got tripled. I want this, I want, hold on. I want this, and this. So A3 gets tripled as well. So if there's 3 times, A3 is good as well. So A3 got 3 times. Now A2 only gets 2 times. And A1 only gets 1 time. So A2 have remove 1, and A1 we have to remove 2. So if we're looking at the front, if we count from here, count from A3. What if we don't count from A3? We count from A1 and A2. Right? If we count from A1 and A2, then now we have to count to A3, or they all end at A3. So we count A3, so we have A3, right, 2, 3, and a 1, 2, 3. But what we have is that how do we get rid of the 0? Because they all start from 0. Wow. Amazing. Alright, that will be it. I'll see you guys tomorrow. Adios.